So I'm going to try to help you guys out with the universal gravity simulation. We're going to use Physics Aviary, which is this link here. And that's going to take you to the actual program. That's what this looks like here when it says Universal Gravity Lab begin. And then coming back to the original information sheet, the second link here is for you to do a graph. So this called Quick Graph, and this will help you kind of make a graph out of your data, and that way you can make a sketch really easy. Okay, so coming back to here, what we're going to do is we're looking at the factors that affect the force of gravity between two masses. So this first part, we're going to change the separation or the distance between the masses. So that's going to be what we're going to change. So mass 1 and mass 2 are going to be some set values that we're going to keep the same, and then we're going to measure different separations. So these are like, this is like the trial 1 through 10. You're going to change the separation between those two masses, and you're going to get a force. And you want to make sure you're in micronewtons. So micronewtons is just a small version of newtons. It's like newtons times 10 to the -6. But we're not going to worry about the exponent so much. It's still going to show you the same relationship. So that's going to be what we're going to do. We're going to plot that data on our graph, and then all you have to do is really sketch it. So you can attach the quick graph if you want, but you can also just like sketch what's going on here. So, and then from that sketch, you're just describing what's happening. So as the separation gets bigger, what happens to this force? How does it change? We're going to go through other parts of the lab as well. So part 2 is changing the mass. So we're going to keep mass 2 the same, and the separation or the distance between them the same. And you're just going to change the value of mass 1. And then again, do the same kind of plotting on a graph and sketching and writing out that description. So as mass 1 increases or gets bigger, what happens to the force? And then finally is how mass 2 affects the universal law of gravitation. So that's sort of the overview of the lab. Let me just kind of take you through the functionality of the simulation. So after you get this set up, you kind of look at, these are kind of like 2 force probes, and these are 2 masses. So let me see if I can hide this. I think it's in the way. Okay. So you see you have object 1, which is the object here, and object 2. These arrows just move the object. So you can move the object to the right, you can move the object to the left. That's fine. I'm going to move the objects pretty close to each other to start, and then I'm going to start by moving them apart. So it'll be displaying what happens as the, it'll display the force as the separation or the distance between them gets larger. You also can show a ruler. So if you look at the ruler here, wherever this first object is, the center to the center is what you're measuring. So this is about 3 meters away right now. For object 1, you can change the masses. It doesn't really matter. I would just make it so that it's fairly big. So for both of them, and then for the force, it reads the force. So this is a measurement of how much force there is. And this is that micronewton scale that I was talking about. So this little cursive that looks like a U, and it says it's 503. So if I wanted to record this piece of information, and you just click back on the thing, we are 3 meters away. So that would go in for the separation distance is 3. And then the force would be that 503.7. So I'd put that in. Then I could go over here, and the thing you change, that's going to be the separation in this one. You can type this in if you want, but it's separation and meters. That was the thing that we measured. And then for the Y, or the thing that we're putting on the vertical, that's going to be the force, and that's going to be in those micronewtons. So I just put UN for that. And again, you can attach this as a file. You can like copy and paste the web link up here once you get it constructed. But we're going to put 3, and then we're going to put it's like 503.7, I believe. I'll go back and double check. Yeah. Okay. So then what we're going to do is we're simply just going to make the objects get further apart. So I'm just going to move this some distance. So maybe I moved it. It says we got to move it 10 spots. So that was pretty close to 3. It's a little bit off, but it's not the end of the world if it's a little bit off. You're just going to estimate. So I'm going to move it a little bit further away. So this looks like it's 3 point maybe 4. So 2, 4, 6, 8, 10. Yeah. So it's divided 5 sections. So it's 20 0.2. So this is like 3.4. So I'll look at the force again at 3.4, it's 390.5. So I can say this is 3.4, and then I'm going to put 390.5. So I'm just going to continue to take data like this. So I'll do a couple more just to give you the idea here. Oh, wrong way. Sorry. So we're at 3.4, and now I'm at like 3. That's pretty close to 3.8. So 3.8, and the force for 3.8 was 311.5. So just typing this in, and you can start to see some data points collect over here, and we'll keep going for a couple more. So I don't know. Wrong way again. Sorry. So that was 3. So it's like 4.2 there, and 4.2. I'm at 254.3. And your data might be different because your masses might be different, or you know, that's generally the thing that's going to kind of change it. I'm going to keep moving it, and I'll move one really far away. I don't know, I'll move it to like 7. So 7, when it's 7 away, we got 90.6. Right. And I could go a little bit bigger or distance if I wanted. Let me try to get maybe one more, just to show you that like you can go pretty far. And I want to try to maybe possibly show a mistake that could happen. So that's like as far I think as I can get it. Let me see the force here. All right, so I'm still within the range. Let me try to move this object here so I make it even further apart. So all right, almost there. I just don't want you guys to make this mistake, so that's what I'm trying to point it out. So I don't know if I can get it with these two, but and I couldn't. But eventually, sometimes this will change from this cursive U or micronewtons into millinewtons, and you don't want to do that. So you just want to consistently be in micronewtons. So get 10 data points that are all micronewton values, and you'll get good results. Okay, so we'll just go with the data that I plotted here. So this looks like our data for those 4 or 5 that I did, and then you're going to hit curve fit. So on this one, it asks you to curve fit and to put an inverse square. Sorry. And you can see the data lines up really nicely, and that would be the equation for it. And it follows this inverse square law. So you would just kind of look at this graph, and you could sketch this on your on the original sheet that you're going to turn in for a grade. And you would say, okay, as my separation got bigger and bigger and bigger, so as this value went further and further to the right here, my force got smaller, and it varied with an inverse square. So that's kind of what you're doing for this lab. For this other 2 parts, the only thing you're going to change is, so you're going to get them to some separation that you like. So I'm going to move them back together so they're not so far away. So we'll put them pretty close. And what you're going to do is you're going to change the mass of one of the objects. So maybe we start with this object here, and we started with this data, and we'll look at the forces, and we collect. It's 174.7 for, for this distance, which looks like it's about 5 away. And that's for the mass for object 2. I'd write that information down. Object 1, you'd write that information down. And you should write that down for all the parts. And as you change them in your lab, that'll have an effect. So, so for the force there, I did that and got that force. Then I'm going to take that object and I'm going to make it get bigger, maybe. So there's a bigger object, and then I'm going to collect the force, and my force got bigger. So, so you're just going to keep doing that, and you would, instead of having separation here, you would have mass, and you would change this data because it wouldn't be the same numbers anymore. But you would get another graph, and you would do a curve fit again as it describes on the paper, and you go through there. So hopefully that's a good enough explanation to get you guys started on this simulation lab. And again, always, if you have questions, you can always email me, and I will try to clarify anything that you need help with. Okay, so have a good one, guys. I'll talk to you later.